Hello, class. We are the plant monitoring team. My name is Christian.
I'm Andrew.
And I'm Sean.
Through the last year or so, many people picked up plant care as a new hobby. Those who did quickly learned that it can be a challenging task to keep track of each plant and their needs in order to keep them happy, thriving, and alive. As a solution, our team built a system that is able to water the plant if needed and keep track of a plant's status in order to monitor soil moisture, ambient temperature, and humidity. Within our system, each parameter can be customized and set to specific ranges that are tailored to a particular plant's needs. If the plant falls out of the set parameters, the system will automatically water the plant if dry, or an alarm will trigger and signal that the plant needs additional care or to be moved to a different location. Overall, we were successful in achieving our target design specs and functional requirements. From the start, we set out to spend less than $100 on the project and to be able to maintain and monitor ambient temperature, humidity, and soil moisture within specific ranges.
When we were designing our mechatronic system, we wanted the algorithm to look something like this. The board would get power and code from a computer. Sensors would get data from the plant and feed that information into the board, which would then act accordingly. If the soil moisture was too low, water would get pumped in by the pump. And if the temperature or humidity was out of range, the board would play a noise notifying the user that the plant needed to be moved. In order to enact this vision, we decided to use an Adafruit Clue, an Adafruit Bonsai Buckaroo, a 3-volt DC water pump, and alligator clips with screws. Here's our electrical schematic. It's powered through a USB connection to the computer, and the Clue and Bonsai Buckaroo are connected through 5 pins. The pump is connected through a 3-volt out and ground, and alligator clips are connected to the 3-volt and pin 1s on the bottom of the bonsai, and the other ends are plugged into the soil.
We decided to use the Adafruit Clue because it has an LCD screen display. We thought this would be a great idea to be able to monitor the environment in real time. This would present more sensors and challenges. As for the code, the figure on the left shows us defining variables and sensors and also assigning values for temperature and humidity parameters. The figure on the right shows us setting up the Clue display text size and colors and also is the start of the main loop. This is the main while true loop. You can see throughout the if, elif, and else statements that we have humidity and temperature, and depending on if it's lower or higher than the min and max, the alarm will be equal to true, which will set off a tone at 2000 Hertz. Also, towards the bottom, you can see the if percent for the moisture. If it's less than the set value, the motor value will be true, which would be on. This is the demonstration for our project.
Hello, this is the plant monitor for 106. Here we have the LCD display that's connected to our custom board. We have the custom board that connects to the 3-volt motor as our actuator, and that motor has a pipe that will transmit water to the plant. It also has 2 alligator clips that are connected to the screws, which will send an electric signal to detect moisture. So we have the temperature and humidity that will be a controlling environmental factor, and the alarm will go off if those are below a certain min and max that the user can set. The other one is the moisture level in the soil, and if it's below a certain parameter, the motor will send water to the soil. So to demonstrate the first one, which is the temperature and humidity, right now it's set and the plant is in a happy environment, but I'm going to set it to a low temperature and a high humidity for the plant. So as you can see, the alarm goes off. That will notify the user that the plant is not in a happy environment, and you can see by the LCD screen, the temperature is a min, so it's blue, and the humidity is a max, so it's red. So now after that, it should go back to being in a happy environment because I set the values back. So depending on what plant you have, you can set that. Now I will demonstrate the motor. So because we ran some demos, the soil is already really moist, And you can see the percentage is 99. So I'm going to set it to 100 and we're going to run that. And because it's lower than what the user wants to set it at, the motor will start working right now. So you can see the water will start going to the plant and the motor will send every 1 second. And it'll go motor on and motor off. Thank you for watching, and that is how our plant monitoring system works.
Through the process of this project, the team quickly learned that effective communication and time management was crucial for teamwork through the COVID situation. We learned more about coding and setting up new microcontrollers with new libraries, and testing them little by little was an important aspect for success with this project. If we were to do it over again or have more time to work on the project, it would have been nice to see the plant move itself instead of just having an alarm sound off, and to test our project over a long period of time with a variety of plants. Thank you for listening to our presentation, and we will now take any questions.